Have you ever wondered if time travel could be a reality, not just a concept in sci-fi books and movies? Time travel, the idea of moving between different points in time, has captivated our imaginations for centuries. It's been a popular plot device since the 19th century, turning up in countless novels and films. Yet, despite its prevalence in fiction, time travel has never been practically demonstrated or verified. Some argue it's impossible based on our current understanding of Newtonian physics and special relativity. These theories suggest we're always moving forward in time at a steady, unchangeable rate. There's no reversing or fast-forwarding according to these models. However, general relativity does tease the theoretical possibility of time travel, suggesting we might be able to move backwards or forwards in time, independently of the normal flow of time we observe on Earth. So, time travel remains a fascinating yet unproven concept, but let's delve deeper into it. In the realm of physics, time travel isn't as straightforward as it appears in fiction. Let's delve into the Newtonian and relativistic views of time to understand why. In the Newtonian view, time is absolute. It marches on at a constant pace, never slowing, never speeding up, never reversing. We, as mere passengers, move deterministically and linearly forward into the future. This concept of time is akin to an unstoppable train on an infinite track, always moving, never changing direction. It's a one-way journey with no way back. So, in this view, time travel, particularly to the past, is an impossibility. Now let's shift gears and look at Albert Einstein's special theory of relativity. According to this theory, we are constrained by our light cones, regions of the universe that we can affect or be affected by. Time, in this view, is intertwined with the three dimensions of space, forming a four-dimensional space-time. But even within this space-time, our trajectory is always forward. The past remains out of reach and the future is always a step away. So, where does this leave us with our dreams of hopping in a time machine and visiting the past or future? Well, according to these theories, it seems we're stuck in the present, ever moving towards the future with no possibility of a detour or a step back. It's as if we're on a boat on a river, the current always moving us forward with no chance to row upstream or pause to float in place. But wait, don't pack up your hypothetical time travel luggage just yet. While time travel may seem unattainable in the Newtonian absolute time and the special theory of relativity, general relativity brings a twist to the tale. It introduces the idea that time and space are not separate entities but are combined in a four-dimensional fabric called space-time that can be warped and twisted. This opens up fascinating possibilities for time travel that we'll explore in the next scene. Time travel, as per these theories, seems unattainable. However, general relativity brings a twist to the tale. Einstein's theory of general relativity opens up a new perspective on time travel. This theory, unlike Newtonian and special relativity, allows for the theoretical possibility of time travel. Now let's dive into the concept a bit more. Picture time as a vast ocean. We humans in our everyday lives are like ships sailing forward on this ocean, moving from the past into the future. But what if our ship could navigate not just forward but also backward? What if we could sail against the current of time into the past or speed up to reach the future faster? This is the concept of time travel in the context of general relativity. Imagine being able to move back and forth in time independently of the normal flow of time we observe on Earth. It's like having a time compass that points not just to the north or south but also to the future and the past. This means that, theoretically, we could revisit historical events or leap into the far future. However, it's important to note that this doesn't mean we can simply jump into a time machine, press a button, and instantly find ourselves in a different era. The idea of time travel, according to general relativity, is not about teleporting through time, but about changing the rate at which we move through it. The most common example of this is the twin paradox, a thought experiment in physics. If one twin travels to space at near light speed and then returns, they would be younger than their sibling who stayed on Earth. This is because time passes slower for the traveling twin. From their perspective, they've time traveled into the future. So, general relativity does raise the theoretical possibility of time travel. But remember, these are just theories, and the practical implementation of time travel remains a big question mark. The idea of time travel is intriguing in the light of general relativity, but how would it look in practice? That's a question that continues to fascinate scientists and dreamers alike. As we sail forward on the ocean of time, who knows what discoveries await us on the horizon? Opening. Various speculative time travel solutions and scenarios have been proposed over the years. Now let's take a journey into the depths of these theories. Picture a universe where we could traverse time as easily as we navigate space. This is the essence behind many time travel scenarios, which often depart drastically from the physical machine with levers and dials that H.G. Wells envisioned. One of the most intriguing concepts in these scenarios is the idea of closed time-like curves. In this model, an individual's time cone, the path that a hypothetical light signal could take, twists and folds back onto itself. This allows a path from the present to either the distant future or even the past. It's like looping a piece of string and tracing your finger along it, ultimately ending up where you began. This concept was first proposed by Kurt Gödel in the early days of relativity and challenged the dominant idea of linear time that was the foundation for much of physics. Gödel's solution was a special case, based on an infinite rotating universe, not the finite, non-rotating universe we inhabit. But it opened the door to other time travel solutions that didn't require an infinite rotating universe. The implications are staggering. Imagine a world where time is as fluid as water, able to flow forward and backward, where we could revisit the past or leap into the future at will. It's a tantalizing prospect, but it's important to remember that these are speculative scenarios, not proven realities. Now, it's also crucial to note that these scenarios are contentious. While they provide a theoretical framework for time travel, the actual physical plausibility is uncertain. It's one thing to theorize about time travel in the abstract, quite another to demonstrate it in the real world. Closing. These scenarios make time travel seem plausible, but are they physically possible? As we continue our journey through the enigma of time travel, we'll delve deeper into the controversies and the realities. But for now, let's revel in the possibilities and the questions they provoke. After all, it's the questions that drive us forward or backward. Physicist Frank Tipler stirred the scientific community with his time machine proposition. This unconventional idea was far from a simple contraption with gears and levers. Tipler proposed a time machine that was as fascinating as it was debatable. His idea was based on an infinitely long cylinder spinning along its longitudinal axis. Now you might be wondering, what does a spinning cylinder have to do with time travel? Well, Tipler's theory is grounded in Einstein's field equations of general relativity. These equations, in certain circumstances, allow for the existence of closed time-like curves, where an individual's time cone twists and closes in on itself. This twist theoretically allows for a path from the present to the distant future or the past. Tipler's spinning cylinder was a way to exploit these curves to create a time machine. According to Tipler, an infinitely long cylinder spinning at high speeds would create a sort of gravitational vortex. This vortex, in theory, could twist the fabric of space-time around the cylinder, creating those closed, time-like curves. Imagine being able to step into this vortex, to be swept along these curves from one point in time to another. Tipler's theory suggested that this type of time travel, both forward and backward, was possible without violating the laws of physics. This proposition was groundbreaking, but it was also controversial. Critics argued that the concept of an infinitely long cylinder was problematic, as infinity is a mathematical concept, not a physical reality. Others pointed out that even if such a cylinder could exist, the energy required to spin it at the necessary speeds would be astronomical. Despite these criticisms, Tipler's time machine has made a significant impact on the discourse around time travel. It has sparked debates, inspired research, and challenged our understanding of the universe. Tipler's time machine may sound promising, but it remains a contentious theory within the scientific community. As we continue to explore the enigma of time travel, who knows what future discoveries may reveal? So, where do we stand on the reality of time travel? That's the million-dollar question. We've journeyed through the enigma of time travel, explored the Newtonian and relativistic views, dived into general relativity, and considered various time travel scenarios, including the controversial time machine. We know we're always traveling through time, moving from the past into the future. Yet, changing the rate at which we travel into the future, or reversing it to journey into the past, remains a tantalizing concept. While Newtonian absolute time and special relativity constrains us, general relativity opens the door, at least theoretically, to travel through time. We've also seen that under certain conditions, like traveling at relativistic speeds, one might experience a form of time dilation, effectively fast-forwarding into the future. Yet, the actual physical plausibility of these scenarios remains uncertain. While time travel continues to captivate our imaginations, its reality remains a mystery. waiting to be unraveled by the relentless pursuits of science.